morning, good afternoon, good evening, depending upon where you are in the world. Most welcome to this ABB Robotics webinar. My name is Arvid Wiebom and I will be the host and moderator, and I'm really happy that all of you could join us. Really glad that you took time out of your calendar to be with us here in this event today. So the topic, it's enhanced productivity and performance for the OmniCore. And we have a great lineup of speakers with us today. So starting us off, there will be Thomas Reisinger, who is portfolio manager for General Industries related ABB. Also Peter Fixell, who is the global product manager for robot controllers. And we are also joined by Michelle Wang, who is the global electronics product and portfolio manager for IRB and GOFA Ultra Accuracy. I'm hoping I get that title right there. It's quite long, but most welcome to the team. And a few things before we get started. Today, our participants will stay muted throughout. So if you want to interact with us, there is a chat. You could use the chat to provide feedback and ask questions. So please do so as we go along in the presentation. And once we get to the end, we will hold a Q&A where we go through all of the questions and try to answer them. So take this opportunity, ask some questions, and help make this webinar a little bit more interactive. That being said, it's time for me to hand over to Thomas. Most welcome. The floor is all yours.
Thank you very much, Arvid, and welcome and thank you for being here. So we are very happy to talk with you about the enhanced productivity and performance of OmniCore. We officially launched OmniCore for our entire product family, and we can't wait telling you all the amazing things you can add to your production. Today's webinar is about performance and productivity unlocked with OmniCore. Stay tuned for the next minutes. We also want to make sure that you can ask questions. So we'll take out 15 minutes to introduce some of the key value drivers for OmniCore, and then we will open up the floor for questions. So what can you expect today? So the webinar is about the introduction that you're listening to me right now. Then there is cybersecurity that enables the digital and flexible factory of the future. OmniCore controllers are designed for the digital manufacturing ecosystem, and Peter will guide you through the cybersecurity. Then we dive deeper into the motion control because OmniCore provides the best motion control and performance on the market. It builds on the strong history of through move and quick move and improved performance for the new robot models. Automatic path planning enlarges the performance to path optimization. All this you will hear from Peter again on the third section of motion control. And then Michelle and myself will conclude on productivity and applications, really giving you tangible results on how OmniCore can unlock productivity in the applications. And the Q&A will, as said, conclude this session, and we are really looking forward to answer your questions, as Arvid mentioned it before. But before we go into this one, and still sticking in the intro, we would like to walk you down the memory lane and see how ABB has developed to deliver its core value propositions to you. Starting in 1974, our first controller S1 has been launched, and it was the first one using an 8-bit microprocessor to controlling a robot. And the control was for all 5 axes of the robot, but all the control has been independent, meaning that the path accuracy was not at the level as it is right now. This starts to be improving 1980 with the S2 generation of our controller, where the first time it was kinematic models included in our controller, and now it was possible to move along lines, meaning that you can really think about path applications instead of just point-to-point applications. And we will dive deeper into what the meaning for this one is about. Then the next improvement came in 1985, where we implemented rigid models and simple rigid dynamic models, where the control performance was even more improved, and fast forward control was introduced. Now we could compensate for some disturbances in the model, but still you need very sticky and stiff manipulator structures to have a decent motion control performance. And again, a step forward was 2005 with the S5, S4 and IRC5 controllers, which complete rigid and elastic models. Here, the first time we really could benefit from all the great performance for quick move and true move and absolute path accuracy from our robot controllers. Now the robot models could be used to control beforehand the weaknesses of the dynamic structure of the manipulators, and you could build manipulators dedicated to applications at the top-notch technology. Now in 2024, we even introduced full model-based control in our control platform, and we are starting to support machine learning and even more sophisticated dynamic models with OmniCore, and we're going to talk with you about the performance enhancement in this webinar. But it's not about, but there is, on the one hand side, there's motion control and performance in motion control, but there is also, but at the end, you're very interested in productivity, because the productivity, you're interested in productivity for the application, and our complete ecosystem to program a robot like Robot Studio and Rapid seamlessly integrates in the new OmniCore controller for all types and sizes of manipulators. It allows to realize any application in modern production technology. Many of these applications are supported by dedicated application software. Today, we show you how OmniCore increases productivity for the spot welding, assembly, and dispensing applications. And having said enough for the introduction, I hand over to Peter for digitalization and security.
Thank you very much, Thomas, and welcome to the part where we talk about digitalization and security. So if we imagine the travel we have done since 1974, you were super happy just to run an application and to replicate that application over and over again to produce your parts. Now, in the last years, we also have seen there is a need to collect information. You want to collect information from your robot, from multiple robots, complete lines, accessories, and process equipment, because that gives you knowledge. And with knowledge, you can always create information and tangible tasks that you can act upon. So this is really the trend we see. Next slide, please. And in this environment, the key part of the robot is to be connected. So if you are connected, you can share information with your company portal, with suppliers, whoever wants to be a stakeholder in this game when you are connected. It can really give you the opportunity to optimize your factory. You can do fault tracing in an easy way. You can get experts to help you, even though they are on the other side of the globe. Really gives you the opportunity to run your business in a super efficient way and to continuously improve on your performance. So connectivity and digitalization is really here to stay, and I think you agree with me. Even though we have seen it in other areas, we know that factories and automation is coming there as well. And to be able to run this one in a safe way, because it's really, once you realize you want to connect, then the next question is, can I do it in a safe way? So within the OmniCore architecture, we have really focused on cybersecurity. Cybersecurity means that we take care of and make sure that when you run your operation, when you share data, you do that in a safe way. Equally, when you download your software, when you initialize your processes, either way you interact with your robot system, you want to stay safe. And there are some 8 elements that we have been targeting, like user authentication. Do not allow everyone to do everything in your system. Secure protocols, secure boot. Secure boot meaning that we will only allow approved files to be executed. And if they are not executed, if there are some malware or some evil people that want to touch your operation, then they will be blocked. Secure credential means that if you have passwords, they are safely saved on the controller. Not even we can extract them. They are bound into the hardware. So really a full way of making sure that you can run your operation safely, making sure that no one will touch your system, even though you are connected, which you want to be because you want to optimize. So really, this is what we do. This is the really new thing about OmniCore being cyber secure, being available there for your digitalization and taking your production to the next level. Next one. So this is a little bit like a smorgasbord for us coming from Sweden and telling you about some pitches on what we are doing. The next thing about productivity, I really want to talk about ABB motion control. If there's something we are super proud about and we know that we are known for, is our productivity. So the motion control, really making sure that what you program is what you get. What you see is what you get. This is really key to enable faster or shorter cycle times and always follow the path. So on the next slide, I will show you the two keywords we have when we talk about the out-of-the-box performance. The first one is true move, and the second one is quick move. A true move means we will always stay on path. And if you look at the pictures on your right, and there's a staircase illustration and a circle at the bottom part. You see also the red and the yellow path. There are competitors. They are trying to follow this path and trying to do the best. One is very slow in reacting, and the other one is overshooting. So more or less, you are not following the path that you anticipated when you were writing your program, when you were designing your application. Whereas the blue one, you can't hardly distinguish from the black one. The black one is the program path, the theoretical path, and the blue one is the ABB path where we follow and make sure that we always stay on path. And this is really speed independent, up to the speed of 1600 millimeters per second. This is really critical that we still follow the path. And you might think that this is super good for dispensing or continuous applications like arc welding, but I will say it's equally important for you when you are test running at slow speed. When you crank up your speed, of course, you want to stay on path. You don't want to have additional collisions or any other malfunction in your process. And talking about quick move, that is a way to really have a quick start from zero speed and getting up to the correct speed, also reducing and stopping. So that will give you like 25% shorter cycle time. And we take the next one. And this is my friend. It's James. Now we have talked about we follow the path we program, but the next question is, okay, so how do I generate my path? Traditionally, James has been there manually teaching or using Robot Studio to manually teach in Robot Studio and creating the path of the robot. But there's always some tricky things about creating the path. You need to know the environment. You want to make it as short as possible. You have productivity targets you want to meet. So here we have something to help you. Really a super cool feature bedded into Robot Studio. And that function is on the next slide. I have a co-driver. His name is Thomas. Automatic path planning. So what automatic path planning does for you is you define a starting position and you define your end position. And with the starting and end position, you also have implementation of the tool and the part. You also have a CAD model of your installation, which illustrates the equipment you have, the machines, any infrastructure that like pillars or roof. When that is in place, you just press a button and in 2 seconds, automatic path planning will generate the path for you. Whereas if you did it manually, that would be like 45 minutes where we tested with different users. So they ended up like 45 minutes to create this path. But there's also, apart from saving the time for programming, you have a lot of benefits, like the cycle time is reduced from 3.2 seconds to 1.7 seconds, and the energy consumption is reduced by 36%. So it's all positive, all benefits, and all is included in Robot Studio just by a click of a button. And once you think that, okay, so now we have it in Robot Studio, how about making it available for a dynamic environment where I can generate the path every time I need a path? So in December, we will release automatic path planning online. And online means that if in this case, we are using a robot, we are picking boxes out of a pallet, and if you have a camera that identifies the new location for picking, the system will automatically generate the best path for you. So if you look at this example, the path is actually not identical from time to time, and that saves tons of time. And the next one is me handing over to Michelle, I think. Yes, Michelle, stage is yours.
Thank you. In the next session, we'll be focusing on how OmniCore supports ultra accuracy and the applications of such refined technology. Let's start by exploring the key features of ABB's GoFar Ultra Accuracy. This innovative technology achieves a path accuracy down to 0.03 millimeters, making it 10 times more accurate than other cobots on the market. Additionally, it offers outstanding absolute position accuracy of less than 0.1 millimeters. With a class-leading post-repeatability of 0.02 millimeters, it delivers reliable results consistently. This innovation sets a new benchmark for precision and flexibility in manufacturing applications. Now, let's talk about how OmniCore controller supports GoFar in achieving these precision levels. Besides GoFar's advanced hardware, ultra accuracy is made possible through revolutionary motion control. Let's not only includes ABB path accuracy, high path accuracy delivered by TrueMove, but also better handles disturbances and uncertainties by employing on-site information to enhance servo loop performance. The OmniCore controller provides enhanced processing power and uses advanced motion control algorithms that fine-tune path and position adjustments, ensuring superior precision. Additionally, its real-time data processing allows immediate adjustments, even in the most complex applications, ensuring consistent accuracy. It's also supported by ABB Absolute Accuracy, a calibration method that provides high precision accuracy that seamlessly adapting to offline programming. These features, along with ABB Robot Studio, bring our customer precise, reliable, and flexible automation from design to implementation. Now let's take a look at ABB GoFar Ultra Accuracy video. Okay. GoFar Ultra Accuracy is a technology that can bring automation precision to the next level. It can be applied to all industries that require precise applications. Thank you for your attention. And now I'll pass the floor to Thomas.
Thank you very much, Michelle, for this great introduction. And you have the luxury to see Peter twice, live as well as on a video here. But let's now demystify some of the rumors that are relevant for talking about productivity, something we call productivity basics. So data sheets very often list maximum speed for every access of a robot. And you can find a quite diverse picture on all the data sheets, but these values do not tell you the complete truth. Relevant for your productivity is the cycle time, and key to reduce this cycle time is the right coordination of the access, knowing the exact dynamic model of the manipulator. Based on our quick move and true move technology Peter introduced before, that's not just some headlines you see on our data sheets, is really the achievement of the fastest cycle time you get for an industrial robot, and therefore it boosts your productivity. So keep in mind, access speed is not the complete truth. It's about the real access speed is not the real. It's not the real truth. It's about the fastest cycle time, and ABB provides you the fastest cycle time, taking the quick move and the true move approach in the motion control of their controller. And making this even more tangible, we can talk about productivity in point-to-point applications that can be shown using the cycle time benchmark for spot welding. On the right-hand side, you see a video looping of a typical spot welding application. The gun is moving from point to point and is putting a space. So for point-to-point application, it's not important how the path of the robot is in between the point, but it's of superior importance that we have an accurate point and that it moves fastest from one point to another. So, and if we compare the point-to-point performance of ABB with some of the competitors, we really outperform them, and you can calculate this performance increase or this performance boost of ABB robots with our motion control performance, that ABB robots can produce up to 6 cars more in one day in a typical automotive spot welding line, if you assume a certain size, a certain number of spots on a car. And this really gives you a tangible figure how ABB motion performance outperforms our competitors and really helps you to boost productivity. The same is also true for path applications. And let me start the video. You can see on the right-hand side a dispensing application where our class-leading path accuracy can be seen in action. The first time the robot is moving with quite some moderate speed, and it's exactly following the application and the path that you would like to achieve. But it's very, very important, and it's crucial for the productivity of this application that you can run this path even in higher speed. And you will see this right now. It's exactly the same path. The robot is moving with a double speed, and the path is exactly the same as before. This means you can double the productivity, and taking into account all the side effects with this, you can keep the process quality independent of the robot speed, which results in 25% increased performance if you use ABB robots with our superior motion control performance. What we have told you about the motion control performance is not only true for moving a robot, but we also we reduced the commissioning times for weeks to hours by having pre-engineered applications in our offering. We support all major communication protocols for easy third-party integration. We have HMI-based customizable flex pendant and on. So we are not only focusing on motion control performance, but also in reducing the commissioning times for our system integrators and for our end customers if using ABB robots. This is concluding our insights into the capabilities of OmniCore regarding enhanced productivity and performance. And we are happy now to take your answers. And before handing over or handing back to Arvid, I would like to make you aware of the next webinar that is upcoming on January the 23rd. And there the topic is energy efficiency, a topic that is more and more important for all of our customers by driving sustainable productivity. So stay tuned and put this maybe already in your calendars. And now I'm handing over to Arvid for moderating the questions and answer sessions. Thank you.
And you are muted, Arvid.
Yeah. I saw I needed to unmute there. No webinar is perfect without the reminder to unmute. So it was me at this time. But I was saying that I just wanted to thank all of our presenters for doing a great job with the presentation part here. And we are now open for questions. We had a few questions come in while you were presenting, at least one. So if you do have a question for us, please go ahead, use the Ask the Speaker chat, and we will be happy to answer. The one question that came in is, what kind of camera feedback is needed for the dynamic automatic path planning?
I guess that one is for me, isn't it? So we are completely camera agnostic. So if you have a camera that can identify the box itself, that is a camera we need to have, because what it will deliver to the robot system is a picking position. Once that is done, we can start to generate the path in between the picking position and the leave position.
Perfect. Thank you very much, Peter. Let's go ahead and see if we get some other questions. While we're waiting to see if we get more input, I can just remind everyone that the webinar is being recorded. So we will send a thank you email to all of you that participated with a link to the recording so that you can review it. Follow-up question here, is it possible to have ultra accuracy in the existing GOFA?
I will take that one as well. I would say yes. All the hardware is included in the GOFA structure already from start. What we have done is to add a lot of intelligent software on top, and you can recalibrate the robot, of course. Now, the process to do it is to send the robot back to the factory, because we need to have the factory equipment to do the calibration. But yes, it's possible.
Perfect. Thank you, Peter. So once again, we've emptied out the
maybe, Arvid, while we are waiting for other questions, we can show this QR code for further information on the webinar I just mentioned. As I said, January the 28th at 3 p.m. CT, there is another webinar. It's right now about efficiency and sustainability. And if I'm right, just scan the code and that you get some more information and to join our next webinar.
Perfect. Thank you, Thomas. So that we have another, let's see here, another question. Perfect. Simon wants to know, is it possible to upgrade an existing IRC5 system to an OmniCore controller?
Yes, definitely it is. But then what you need to do is to replace the full controller. We are supporting the manipulators that are on the market currently. So an upgrade of the controller side from IRC5 to OmniCore means we replace the full controller. There are some differences in how they are designed, so it need also some engineering behind it, but definitely, and that is an upgrade business that we are providing from our customer service and local service organization. So if you are interested, contact your local ABB robotics service organization and they will help you.
Great. Thank you, Peter. Let's see, we have something in this one. Another question came in. What would you say about the energy lost during frequent emergency stops? Do you have any algorithms to optimize this?
Well, An emergency stop for us, typically that is a stop using our servos, and using the servos, we will feed back that energy to the grid. Now, energy efficiency on OmniCore is really an intelligent power supply unit, which can both feed the robot and feed back to the grid once a robot is coming to a stop. If that is coming to a stop through normal operations, or it's coming to a stop through an e-stop situation where you use your servo to reduce the speed, also staying on the path, that is super important. During e-stop situations, we always want to stay on path because you want to avoid any consequence of collisions with equipment as well during an e-stop situation. So that energy will definitely be fed back to the grid.
Mm-hmm.
And there is no loss of energy. You can use it in any other equipment in your factory, like ventilation, lighting, other robots, process equipment.
Mm-hmm. There's a follow-up to this question there. My doubt was about the tear and wear caused due to this condition.
Currently, there, of course, when we design the robot system, we design it for a number of e-stop situations. But I will say, if the e-stop situation is using the robot and staying on path, that doesn't add any wear and tear to the robot. The one that does add wear and tear on the robot is when you go for the category 0 e-stop, as it's called, when you use your mechanical brakes to stop the system. But that is very rare. Normally you would run it as a category 1, which means you stay on path using the servo to reduce the speed. Then it's just another way of controlling the robot, and you don't have any extra wear to it.
Yeah, perfect. Thank you. Once again, I think we have, there's a new question here. Perfect. Hardware aside, what migration steps would be necessary to migrate a system from an IRC5 to an OmniCore? Are there significant changes with regard to the rapid code, or can the programs be easily dropped onto the new controller?
First of all, I would say yes, the rapid program can be dropped on OmniCore. We are using the same rapid commands and the same structure of the programming. Where you will end up in some engineering needs depends on if you have spent hours and designing your user interface on the flex pennant. If that is the case, you would need to redesign your user interface. If you look at the wiring and connectivity of the robot and the robot controller, that is slightly different. You will recognize what it is, but there are different ways of connecting the e-stop, general stop, e-stop status output, etc. The I/O system looks slightly different, so you would need to spend some time to identify how you reconnect all your signals in the system. But apart from that, I believe it's quite straightforward to change from IS5 to OmniCore. And typically that is what we are asking our customers currently when we are transitioning from IS5 to OmniCore. That is to ask them to make this redesign. And so far, yes, it requires some hours, but it's not something that is sort of a hurdle for the operations.
Mm-hmm. Thank you, Peter. While we're on the topic here of IRC5, there's another question here about software. Will all the software add-ins that are present in the current IRC5 be coming to the new OmniCore? If yes, then until when, by which year, will we have the IRC5 add-in on the OmniCore?
Currently, we have all the add-ins, or a majority of the add-ins, already transferred. We have done some last changes to the software. We have been doing also repackaging of the software components and the options we use for software functions, but everything should be in there already now or coming until the end of this year.
Mm-hmm. There was a second part. Secondly, is it better to go with OmniCore controllers and wait for a particular software package, or should we go with IRC?
Well, if I was to choose, I would choose OmniCore every day in the week. We have come to a maturity now that is more or less covering everything we did on IRC5, even though it looks different. If you have a choice now to go for IRC5 OmniCore, I would definitely choose OmniCore. OmniCore is future safe, and IRC5 will be removed from the market in 1.5 years. So if you want to stay safe for the future, go for OmniCore.
Yes, thank you. Next question, what are the most significant advancements in ABB OmniCore compared to previous automation solutions?
This is a little bit larger question. So let me frame it into why we believe OmniCore is better and what we have made as changes. First of all, if you look at the controller boxes, now the controller boxes are 5 in number, starting with E10, which is very small, tangible controller for running up to RB1300 robots. And then it scales through C30, C90XT, V250XT, and V400XT for the largest robots like the 8700 robot. So the portfolio of different sizes and the scalability of the sizes of the controller cabinets definitely is different. Secondly, we have integrated a lot of new robots onto the OmniCore platform. So everything that is new goes into the OmniCore platform and not on the IRC5 platform. So we have a wide range of robots available, from Delta robots, 6-axis robots, palletizers, SCARA robots, and cobots on the OmniCore platform. The next one I would like to mention is the environmental safety. Now, 5-10 years ago, we were happy when we could run robots and got the process and production running, but the requirements are changing. The requirements on, can we really be safe that we are sending all the signals through the production line, etc., etc. So we are really focusing on safe operation. And safe operation is, as we talked about, cybersecurity, how you share data. It's about the safe protocols on communication and also safe IOs. So really making sure that we can trust the operation is really a big deal. And of course, we have been working on the performance, the dynamic behavior of the robots. As we talked about today with Quick Move, True Move, that's really a game changer where we have increased the performance by a factor 2. So there is a lot of things that we are working on to say that OmniCore is a better controller compared to IRC5.
Perfect. Thank you very much, Peter. Next question's quite a long one, so bear with us here. I come from contract logistics background, warehouse operations within 4 walls. We wanted to introduce robotics-driven operations to pick products from shelves as per the placed order, put away incoming products to store in warehouse, etc. We would like to leave the how-to robots. And the question here, how do you implement simultaneously localization and mapping, SLAM, in a robot? And what are the primary changes faced during its real-time application?
Is this a question for you, Thomas?
I was thinking about it. I guess it's a very long question. We cannot dive into every detail of it. It's very interesting. And I would like to talk with you or talk to you about the item picking solutions we offer, for example, for the logistics domain. So we are really building on 3D vision technology to solve and to help our customers to solve problems in the logistics domain. It would be really interesting to dive deeper in your requirement that you're having and understand it even more. And we are really there to help you with this one, because we believe we have a really future-proof portfolio for logistics applications built on 3D vision and artificial intelligence-based vision technology. So I can only refer to this one. Would be great if you continue this one and you contact an ABB salesperson regarding this one. And we are happy to take this one and drive this further.
Yeah. And isn't it true also, Thomas, we already have customers within this area where we have solved it with the logistic, transportation, parcel singulation, etc. So
yes, we have it for, as you said, for parcel singulation. We have it for item picking in various logistics applications. Although that there are reference cases where we can build on, and I'm really looking forward to have to implement more of these systems.
Mm-hmm. Perfect. Thank you both. We have one more question. Can SCARA robots on OmniCore work faster than on IRC5?
Yes, I would say yes, but most of all, we have more SCARA robots on OmniCore compared to IRC5. So we have a wider range of payload, reach, and of course, they are faster. I need to mention one thing that is super important. When you do your simulation of your process capabilities, when you are into the engineering phase of an application, I'm quite sure that you would like to verify your performance before you say and sign off that this design of my application is correct. Then I would recommend you to use Robot Studio for simulating the cycle times and the performance, because in Robot Studio, we are using a virtual variant of the OmniCore controller platform. So it's the same controller platform, same software that we have in the real controller. So if you want to be dead sure on your cycle times during simulation, before you start to consume a lot of money and placing orders for hardware, run Robot Studio. That is the best way to verify your performance you will get.
Mm-hmm. Great. So that was the last input we had. Thank you all very much for your interesting questions. So let's wait a few more moments here to see. While we're waiting, we do actually have a small poll that we would like to run. It's basically just a question. If you have an upcoming project for which you would like to receive any further information on the OmniCore or any other ABB robotics solution, so please, it should be visible on your screen now. So go ahead and put your vote in here if you'd like to receive any further information. All right. We had another question come in here, and it was actually for me, which is very rare in these occasions. So I'm very happy that I actually got a question. Normally I just read them, but the question is if we can have more PowerPack based webinars like the one we had last month for arc welding. And for sure, we can look into that. We have a lot of more PowerPacks that we can do webinars for. So I'll take that request with me and we'll try to set something up for you. So thank you very much for that input. And other question, are there significant changes in the communication between, say, a PC application versus IRC5?
Oh, that's a wide question. Hope I will answer this one correct. So I would say yes, it's a difference because we are using our own commands. If you want to extract data or push data to the robot system, definitely there is a difference in how you communicate. But we are using Ethernet-based communications. So if you want to run Profinet or Ethernet IP or CC-Link or EtherCAT, we support them all. If you want to extract data, we are using OPC UA or MQTT as transfer protocols of that data. So really, there's a large variety of opportunities for you, but I will say yes, it looks different. But on the other hand, if you are familiar with communication protocols, I wouldn't say it would be a problem for you. It's a dialect of what you already know.
Mm-hmm. Yes, thank you. Another question came in. Does OmniCore reduce the vibrations and energy lost due to this? Could you talk about the heating reduction in cobots after OmniCore?
I'm not sure if I'm answering the wrong question. Please put a new one in the chat. OmniCore by itself it's designed with a bidirectional rectifier. So it saves you energy. When you're braking, normally what would be generating heat, like the brakes on your car that get hot when you brake. Now we have, similar to a hybrid vehicle, that you feed it to the battery. Now we feed it back to the grid. So we really are saving energy, which of course also reduces the heat generation. The heat generation in the robot by itself is very much depending on the application you're running, how hard you're running, and the efficiency of the motors, the efficiency of the gears, and the payload you're moving. I would say that part is equal in between RC5 and OmniCore, but not the feedback to the grid. That is always only on OmniCore.
Thank you. So let me check some of the channels here. No, I think we don't have any other questions that we've missed. All right. I think then that we will go ahead and close this session. But before we do, I'd like to hand it back to our presenters. If you have some final words or perhaps some key takeaways from this session. So, Thomas, would you please?
Yes. Thank you very much for all of you attending this webinar. It was very interesting, and we really enjoyed our way from talking about cybersecurity, that is the kind of license to operate and that enables a digital and flexible factory of the future, diving really deep into the motion control performance and how OmniCore can help you to improve your productivity, down to the very interesting questions and answers, and hopefully the answers we provided to you. Thank you very much for this one. Please be reminded there is a new webinar coming up end of January. Feel free. We hope you will sign in for this one as well. And thank you very much for your time. And looking forward to hear and see you again.
Yeah, really great to have you. I hope you found it interesting. If you ask me, I could have a 5-hour webinar on all the topics that is circling around the OmniCore, but this was really touching the basis for performance and what we can offer you. But if you are interested, get in contact with us and we can arrange for a longer meeting to tell you all the beautiful things we provide with ABB Robotics. Thank you.
Perfect. So with that said, I'd like to thank you all, our presenters, for joining us and providing us with all of this wonderful information and handling all of the difficult technical questions with these. So thank you all very much. To our participants, thank you for taking the time to join us here today. But that's it for this session. We do hope to see you again in future and upcoming webinars. Bye-bye.